The next topic is GCF primes and absolute value. First, we're going to look at the GCF, the greatest common factor. Now, we've already seen factors before earlier this year. Factors are all the numbers that divide into a larger number. So let's look at the factors of 24, 48, and 36. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 48 are 1, 2, 3, 4, 6, 8, 12, 24, and 48. Notice these are all the same except 48 also has 48. Now the numbers for 36 are the factors for 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Next, we're going to look at what factors they have in common. All three of these numbers have in common. So they all have 1, they all divide by 2, all divide by 3, 4, 6. Notice 8 and 9 are both not factors of all three numbers, but 12 is. Then, to find the GCF, we're going to look at the greatest of them, of these common factors. And so the GCF of 24, 48, and 36 is 12. Next, we're going to take a look at the prime numbers. Now, the definition of prime numbers are numbers whose only factors are 1 and itself. When we look at prime numbers, we always start at 0, and we're going to take a look at the first numbers where the factors are 1 and itself. That would be 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These are all the prime numbers between 0 and 30. Notice 2 is the only even prime number because every other even number divides by 2. Before starting with absolute value, we're first going to do a little intro talking about opposites. Two numbers are opposites if they are the same distance from 0 on the number line in opposite directions. So if we look at this, we notice that R is 2 units from 0, and B is 2 units from 0, but R is placed at -2 on the number line, and B is at +2. So points R and B are opposites because one is positive and the other is, the other is negative. But you also want to make a note, yet they are the same distance from 0. So that's why they are opposites. Let's do some examples here. The absolute value of 5 would be just 5. Now the absolute value of -1/2, if we reference our box up top, the absolute value of a negative number is the opposite, so it's going to be +1/2. The absolute value of -3.25 is going to be +3.25. Now, in order to remember this, I always like to think of this as a car wash. Our car is going in with a negative, So it's dirty, and it comes out clean as a positive. So let's take one more look at another example. What if we have negative absolute value of negative 11? Well, here we're going through the car wash, so 11 is going to come out positive, but here's another negative outside. That's like somebody waiting with mud ready to throw it at your car as soon as it gets out of the car wash. So the answer is actually negative 11 in this case, because the negative is outside the absolute value. Lastly, we're going to look at evaluating expressions with absolute value. So let's take a look at example 1. Evaluate the absolute value expression, the absolute value of 9 minus x, for each of the following x values. Let's first try this one, x equals 2. We get the absolute value of 9 minus 2. Now, absolute value is very similar to parentheses. We're going to simplify inside the absolute value first. So, 9 minus 2 is 7, and the absolute value of 7 is just 7 itself. Let's try this for x equals 10. The absolute value of 9 minus 10, again, we're going to simplify inside the parentheses first, so we get absolute value of negative 1. The absolute value of negative 1 is positive 1, right? We take the opposite. And lastly, I want you to try on your own the absolute, or when x is 12. So substitute that yourself. Simplify inside the absolute value first, and you should get an answer of 3.